to Finish to Design to Field webinar hosted by Carlson Software. My name is Ladd Nelson. I'm the Midwest Sales Director for Carlson, and joining me today is Aaron Newman, who is our South Central Sales Director, and he'll be fielding questions throughout the presentation today. We have a lot of material to cover, so I'm not going to dwell too long on an opening PowerPoint that I have here, but if you do have any questions, feel free to chat those into the GoToMeeting control panel located on the right side of your screen. Again, we've got a lot of material to cover today. I'm going to go through this rather quickly. Today's session is being recorded and will be posted to the Carlson movie page at the conclusion of today's broadcast. As we go through, we'll be talking on some of these main features. We have a lot of, again, material to cover. So with that, I'm going to jump in and start discussing then how today's presentation is going to work. First off, the start of this presentation came from some work that I've been doing with some of the counties located in the state of Iowa who have switched recently over to Carlson Software. And during our conversations with some of these counties, they wanted the ability to collaborate on survey codes between the various counties so they could help one another for the projects that required it. And as we've been talking with them, one of the common things that appeared was that a lot of these counties coded their own data sort of their own way, and they thought it would be sort of helpful to be able to potentially share a unified feature code list, and we opted to create one based on the Iowa DOT feature code list. And on the screen right now is a PDF document that was published by the Iowa DOT that talks about the survey codes and their descriptions of what they use. Complementing that, there were breakdowns in these various codes that talked about what kinds of codes were used for what kinds of considerations. And we assembled this data, the drainage and the waterways and utility kinds of classifications, along with the more verbose descriptions about whether or not these codes are to be included in a digital terrain model should they generate line work, and assembled all that data and placed it into a online Google Docs file that I basically shared with any of the counties that wanted to collaborate. So we essentially generated then a spreadsheet-based online file through Google Docs that had all the different codes, the descriptions. We assembled the layering schemes to conform to the National CAD Standards, and then placed in the categories and the symbol types and all the information that we were able to then glean from the Iowa DOT code list. And throughout this whole process, we had different people contributing to the organization of this material, and as we collaborated on this, then we were able to sort of see what other people were looking for, and everybody was able to contribute their own kinds of materials. So when this list was finally put together, what we did was we went into and basically downloaded this as a CSV file. So I'm going to go ahead and drop this out to a folder on my desktop, a folder that I've got created in here, and I'll just call this my Iowa feature code list, and it's just going to be a CSV file. So we've got that downloaded now, and let me drop out to my desktop here, and out in my feature code listing file in my Win folder, I actually have then the CSV file that we've just brought down. And to get this data and use it out in the field and then also in the office software, what we decided to do was start to work with some of the functionality found inside of Carlson Survey. So I'll load into that real quick just with my IntelliCAD engine for just a moment and sort of show you how we were able to bring this data in. Once Carlson starts up, I'm going to exit out of my wizard and jump into my survey menu configuration. And I went into my survey menu, and I said draw field to finish. I just used a temporary blank coordinate file just to begin with, and wanted to go in and edit my codes and points. Here is actually the assembled list of the various Iowa DOT codes that are actually been conformed to the Iowa Counties standard. And to build this list, I went into my Code Table Settings button and said I wanted to import my text or ASCII codes. And to sort of demonstrate this, I'll just go ahead and create a brand new file out here. So I'm going to go out and click on my Set button, and I'll go back out to that same desktop folder location that I was at earlier and place a new file. So we'll just call this Iowa Counties 1 as an example. So we've already got one out here built, and I'm just going to go ahead and build in a brand new one. There we go. Cancel on that. And we want browse. Make sure I want to go out to my settings folder. And bring in the file. Okay, let's try.
Glad you're on the existing tab. You need to change it to the new.
Yeah, I need to go to new. Sorry about that. That's my fault. I keep getting used to that. So back out. Thank you, Aaron. And we'll just bring in a brand new one here. There we go. So we'll open that up, and just as a quick indication again, then I have basically just a blank file in here, and what I wanted to do was import my text ASCII codes. And again, when I go out and browse for the file that I had or brought down from my Google Docs, I can just click on it, open it up, indicate that this is actually a comma-separated file. My first row actually does contain header information, and then what I can do is match these codes against the different values in my list, and just click on Continue. We bring in 136 codes, and then from there, I can just simply, if I wanted to, export out to SurvCE codes right up here at the top. So I've actually got right now an Iowa Counties FLD file, and from here I could easily convert it out to this Carlson SurvCE codes, and again, just make an FCL file for use as needed. So to take a look at that then, here's all the different values or the codes that came from the Iowa DOT. This is just, again, a quick little default list. We did some additional polishing on that list, and that was what actually was used to generate the Iowa Counties field list that I had earlier, and that's what I'll use. So this is actually, again, with the actual categories, it allows me to sort of split out the codes based on what the Iowa DOT had specified for these different kinds of uses, and we'll get back into this here in just a little bit. But what we want to do now is actually exit out of Carlson with Intelecom, and we're going to jump right into Carlson SurvCE, actually running on the Carlson Surveyor Plus data collector. So through an active sync session and an application called MyMobler, this is actually the actual Carlson handheld device that is tethered to my computer. So what I'm going to do is go ahead and launch into Carlson SurvCE and bring in some of this data, this feature code list, and then use that with some data that's been collected out in the field. And once SurvCE gets loaded, then we'll go ahead and we'll collect some additional shots, take the resulting file, bring that back into CAD, and do some work with it. So I'm just going to go ahead and I want to create a brand new job in here. This is sort of a little temp job, so I'm just going to call this my control points. If I had some, I don't actually have them for this particular presentation today, but I'll just screen check on this and respond to the SurvCE startup that this will be based on U.S. survey feet for the Iowa North projection zone. And to bring in my feature code list, I'm going to go into my File tab and choose Feature Code List, and then just say Load. And I've got my Iowa Counties FCL file that I just created from my Carlson desktop application. And we can load it right up, and here's all my codes with the layer names, and I'm ready to go. Again, since we had done some additional detailing work, what I'm actually going to do is use the actual field code list that I'm using inside of the Office product. So if I go back to load and I want to load up the actual Carlson FLD file format, I can choose it, and I can choose the one that actually has all of my classifications and settings in it. So there's a collaboration between SurvCE and the Survey product where each can use each other's file type or file format. So I'll go ahead and choose the Iowa Counties FLD file format, and when we have this brought in, we will have the ability to say yes. For example, the AST, above ground storage tank, is going to generate line work. It's going to be two-dimensional. It's going to be placed on a survey fuel tank layer, and it has all the different colors and full text and things like that. And these are going to be the codes then that I want to use out in the field to produce line work that would look very similar to what I have inside of the Office product. Complementing that, I'm going to also use some special codes, and we'll talk a little bit more about those later on when we get into the Office product. And I'm going to use the Carlson format, and if I want to begin lines, I can use the BEG code. If I want to put points on a PC, for example, or PT, or if I want to close figures up. Again, these are some of the special codes that I want to use for the Carlson format. For those of you that are not wanting to use the Carlson format, even though it's strongly recommended, we do provide other code types that you can use that are based on different DOT and other organizations. But for today's presentation, I'll use the Carlson format. So once we've got our codes in here and established, then I'm going to go ahead and bring in some data. So I'm going to use my import and export command, and I want to bring in actually an ASCII file that contains actually a couple thousand points that have been coded to this particular Iowa DOT standard. So I'm going to go out and select my file. I've got actually a text file, an ASCII text file that I want to bring in. There's a little preview of it. I'll bring in all points, and we'll just green check. I'm going to put this actually into a Win coordinate file, a brand new one. We'll load up that file and then bring it in. And once we've got this coordinate file specified, then that's actually the one I'm going to be doing my work in. So I'm going to go back into my job menu, choose this new Winnebago County coordinate file, and then work with it. Now, because there are actually several thousand points in here that are going to be producing quite a bit of line work, this will actually take a few seconds to load. But one of the things that I just sort of want to drive home with this is, again, that nice collaboration between the Office software and the field software. The next thing we're going to do once we've brought in the points is Cersei is actually going to go through, read up all this information, look at the existing feature code list that's already been assembled, and then generate the graphical information that I can use in my map screen. And what I will also be doing here is, since I'm actually indoors today, I'm not going to have access to actual GPS gear out in the field. I could be using the Carlson GPS system or others that we support. But today I'm going to actually just go ahead and use a GPS simulation mode. So I'll go into my GPS rover, make sure that we are actually set. I'm going to get off of the last used Carlson GPS, and I'll just go into my GPS simulation and green check on that. And much like a normal GPS rover, the other thing we want to do is make sure we're getting into a fixed GPS solution. So I'll check my monitor sky plot for that. And we're moving here from autonomous into float. We're now into a fixed. We're in simulation mode, and we should be ready to go. So I'll go ahead then and shoot some extra data on here. Just put in a few points that are going to be brought in through my GPS simulation mode. So I'll go into my Survey tab. I'll just choose Auto by Interval. I don't want to collect a lot of data in here. And I'll go based every 5 seconds, starting at point number 2732. And let's describe this as a FCL, which is a fence line. And this is maybe fence line number 2 or 3 or whatever. It doesn't really matter. But this is the second fence line that we're going to place into this data set. And when I green check, we'll switch into our map screen and start to collect our shots. And as we collect the shots then, if I want to, I can change the direction here and sort of navigate around. And at the conclusion of my 6 shots, we'll return out of the auto by interval routine. As a little bit of background, I'm running Carlson SurvCE 2.54 right now. And we'll come back into this later on today for some stakeout work. Okay, so we've just collected our 6 shots, and if I want to take a look at that information, I can go right into my points menu. And down at the bottom, I have, in addition to all the codes that came in from my ASCII file, the FCL codes that I brought in. As a quick visual, I'll just go into my map screen in SurvCE. And there's my data, and I can zoom out a little bit. And you can see that fence line that was brought in. And there actually is quite a bit of information in this job set, so if I go in and just go into my view options, I'll go ahead and freeze all my point attributes just to sort of let you take a look at what we've got. And when I actually do a zoom extents, you can see we've actually got quite a bit of data in here. And this is two county roads that are up near Decorah, Iowa, with the fence line that I just sort of brought in here. So what I want to do now is I've got all this data in my SurvCE job. I'd like to go ahead and bring this data now into the office and start to actually produce field-to-finish work with it. So I'm going to go ahead, exit out of SurvCE. And as I was working with this, one of the things that I did was, let's say note of this, is back in my job settings, that was the other thing I should probably mention, I'm actually storing my data on my handheld device in my Documents folder, and I have a Win folder underneath it. And through ActiveSync or Windows Mobile Center, what I'm actually doing then is forming a data file partnership between my handheld device and my computer. So when I take a look, this My Documents folder on my handheld device is equivalent to my Field PC, My Documents, located on my desktop. And this is sort of the conduit that I'm going to use to share my data between my handheld and my computer. So we'll exit out of SurvCE. And if you notice, then on my ActiveSync screen in here, ActiveSync is going to actually go through, make sure the files are all synchronized. And when I take a look at my Win folder on my desktop, I have the different files that I've produced so far with the DXF file from the drawing, the points that I brought in from the ASCII file, and then any of the raw data and notes and things like that that I've brought in. So now what I want to do is use this information inside of the Office product for my production work. So I'm going to just disconnect for right now my handheld device, and we'll launch into Carlson Survey with AutoCAD. Now I'm going to be we're going to check see if there's any Carlson updates. We don't have anything new. I'm running the current builds. So I'm just going to exit out of my little wizard option here. And this is going to be working at Carlson 2011 with AutoCAD 2010. And once AutoCAD gets loaded, then it'll prompt us for a startup wizard. And what I'm going to do then is build a wizard based on this data file that I just surveyed out in the field. And as you take a look down at the bottom of my CAD sessions in here, I am building my my new drawing based on the Carlson National CAD Standards for my Survey DWT file, a template drawing. So I'll just go into my New option and give it my drawing name, and out on my desktop, I'm going to place this in that same Win folder, and I'll just call this my Win DWG. I'll change the horizontal scale in here and indicate then that for this particular job, we're going to use the same data path that I've got. The coordinate file that I just created, this is an existing coordinate file, and I want to bring points into my CAD session from this coordinate file. And when we bring this in, we're going to use the Carlson Field-to-Finish product of our survey menu. And we're going to use the Iowa County's feature code list that I had specified earlier. And again, if I want to just double check a few things in here, I can look at my codes and my points. The one thing I want to make sure of is that in my code table settings, I'm going to process this using the Carlson coding convention, and that I have my Carlson special codes that match what I have specified inside of my field product. Again, BEG for begin line work if that's what I want to use, PC, PT, close, a lot of these same kinds of codes that we just saw inside of the SurvCE product. Once we have this done, we'll just go ahead and choose Draw and choose OK. And as we go through then, we're going to go ahead and place roughly 2,000, actually about 1,700 points into my drawing, connect up all the line work, specify all the different line work reactors that are going to be going into this data set. And then what we'll do is utilize this information for some surface models. And what I want to do as the surveyor then is prepare my drawing and my data for design. Okay, it'll take us another second or two to get this finished up. There's all of our data. And again, this is information then that we have, including the descriptions for the fence line work shots that we collected through that simulator mode. Again, since this is a little cluttered in terms of all the different point attributes, what I'm going to do is just take a moment and freeze off a few things in here. So I'm going to go ahead and take my point elevation and my point numbers and just freeze those. And that should help clean up the drawing here just a little bit. And one of the things that actually, I'll just go ahead and freeze off the other one here. I was trying to figure out if I wanted to freeze off the descriptions. I'll bring those back on here in just a minute. Is we've got obviously the line work being coded through the field to finish, going on to different layers. We've got tree symbols, culverts that are underneath this data set, utility poles, fence lines. The surveyors that collected this data just did a really remarkable job collecting this and coding this for easy use inside of the office. So what I'm going to do now is I would like to take all this survey data and make a surface model out of it. Normally, one of the things that I would do in here in past is to go through the draw shrink wrap entities routine, but new to Carlson 2011 is sort of an integration with this routine into the surface menu in our triangulate and contour routine. So what I'm going to do here is, actually before I do this, let's just take a quick visual check on all of our survey data. And I'm going to use my 3D viewer window command to do this. And we'll pick up all this data and just check and make sure we don't have any visual busts. And for the most part, it looks pretty good. So as I roll around in here again, we can take a look and sort of see the line work and the points that were collected on the field. And again, it was a very good job that they did with the actual collection itself. So I want to create a surface model now. So I'm going to go right into my surface menu configuration inside a survey, choose triangulate and contour. I've got my labels going to a V, topo minor, and major layer with some settings. Same thing for my contours. I'm going to do 2-foot contours. And again, these are going into the survey, topo, minor layer conventions of the National CAD Standards. And when I actually triangulate this data set, I do want to make a surface model file called existing. Here's the inclusion now of the shrink wrap perimeter reduction command, and I'm going to say for this particular data set, let's apply essentially a medium heat level to the reduction level that's going to go on to this particular data set. And I'm also going to go ahead and ignore anything that might be at a zero elevation. If I happen to get areas where we've got flat triangulation occurring, we're going to minimize those flat triangles and then also interpolate any summits and pits as the system needs to. Let's go ahead and choose all the data for my system in here. It's going to read this, build my contours, and the one thing that I notice in here is that when I select it all, I've got some contours in here that I picked up a point, a couple unknown points that I don't know if I really want or need to use them. So if I simply double click on that point, I may or may not want to actually use it. So if I find out this is an MR, I believe this is like a magnetic reading. We don't actually have a code for that, so this is a quick little indication that we don't know quite what that is. So I'm going to go ahead and sort of rerun the triangulate and contour routine and get rid of those points or not use them for my surface model. So if I go back under triangulate and contour and just simply rerun it, overwriting our surface, this particular example, I'm not going to use that those 2 points down there as my as a basis for my selection set, and that cleans up those contours in that area very nicely. So again, with that shrink wrap boundary option in here, that just saved me a step for the work that I'm doing. So now as we're working through this, the next thing I'm going to do is go ahead and I'll just freeze off, or let me just change a few quick little labels. So if I want to maybe change the location of some of my contour annotation in here, I'm going to go into my Surface menu, Contour Utilities, maybe move some contours along or labels along these contours. I'll just pick up this guy and let's move him down right into there. Let that contour reheal. Same thing there. Maybe make our 970 come up here just a little bit. And let's see, we can probably find another one up here somewhere, but that's good enough for what I want to do. And what I'm going to do next is take this information, freeze it for my display so that I can do some additional work here and get my data ready for design. So I'm going to go ahead and view, and I'll freeze off some layers, and I'll just pick off these couple layers in here. Actually, let's get off that and that. Get all those contours off of there. And I'm going to jump back in and show the point description attributes. And what I want to do next is to isolate onto one of these layers. So I'm going to get to this, just the center lines that are in my road, and I'm going to go ahead and say View, and I want to isolate layers for my center line of road. And it leaves me then with just the two main roads of points that I want to work with. Now, as the surveyor, then what I want to do is provide the designer essentially my rendition, if you will, of a best fit center line that's going to go through the points that I collected out in the field. While in Survey, I can do that through my COGO menu, and I'll choose Best Fit Centerline. I'm going to choose my points from the screen, and we'll go ahead and select off this grouping of points and these last few down here. It's going to go through and prompt me with some tolerances in here, and in this particular example I'm going to use a snap tolerance of 0.1 and a maximum curve radius, if we can find it, of a mile, and I'll just choose OK. And as it goes through, then it'll calculate out the residuals, and I'd say this looks pretty good, and if there were any outliers in here I could throw them out, but I think this all looks alright, so I'll just choose OK. And before I do that, I forgot to do one thing. I'm going to make a new layer. So I'm going to go into my layer control, because right now I'm on my V-Road Center, and I want to create a brand new one. And we'll call this V-Road Center, and I'll just call this maybe Best for Best Fit. We'll make it current, and just to make it a little bit easier to distinguish, I'll give it a color, sort of like a tan color. And that's going to be the layer that I want to have my best fit center lines drawn onto. So again, I'll go back under COGO, I'll do a best fit center line, get my points, and then choose OK. So now we've taken a look at, we actually have two representations in here. We've got, first off, our red one, which has vertices with no curves on them. These are little chord segments, and these were going to be having these little chord segments wherever the center line of the road was surveyed out in the field, versus the more tan-looking one in here. And if we take a look and roll out, you can see that it's actually got just a few items in it. And we'll take and use this here in a little bit for the basis for our roadway center line that we'll be working with next inside of the design application. I'll do this same best fit centerline command one more time on the other road and choose off these points from the screen. Here we go. And again, same tolerances, I'll just choose OK. And again, the residuals seem to be OK, no real major outliers, we'll say OK on that, and there's that center line. So now what I want to do then is take and provide centerline files to the designer so that they can use these, but these haven't quite matched up yet. So what I want to do is just run a standard extend. And I tend to be a keyboard kind of guy, so I'm going to say this is my bounding object in here, and I want to extend off that that center line so that they actually do form a T intersection. And again, as a convenience to my designers, I'll go ahead and build a centerline file for them that they can choose to use if they want to. So I'll go into my centerline. Actually, before I do that, I need to check and make sure that the direction of increasing station is going in the direction I want. So I'm going to just use a tool in here underneath my Edit menu called Polyline Utilities, and we'll reverse these polylines just to make sure that we're going, okay, so now it's going in the right direction. I'll take a look at this one. That's going in the right direction, so everything's good here, and now we'll actually turn them into centerline alignments. I'll use my polyline to centerline command to do that, and I'll call my first one here, this is Middle Kalmar Road, and pick off that polyline, and I'll just assign it an arbitrary starting station of 0 + 0, 0. And rerun the command. This one will be called trout run, and we'll pick off that one. And again, starting station arbitrary, just 0 is fine. And I now have then some data that I want to use for my survey or for my designers. So I'm going to exit from AutoCAD right now, and so as a surveyor I was using Carlson with AutoCAD. As the designer, we'll throw a little bit of a wrinkle in here. We'll actually go out and use Carlson with Intelecom and then reference in these drawings with one another. So I'll jump into the Intelecom product now and use that same survey drawing as a basis for my design work. Now in Intelecom, I've actually got my Intelecom defaulted to use that same survey template drawing. I'm going to choose a different one in here. I want to use the civil drawing template for the National CAD Standards. So if I exit from my wizard and choose New, I'm going to go out and base my next drawing on the Carlson National CAD Standards for Civil. We'll go through the same startup process in here. I'm going to go out and locate my folder or my new drawing back out in that same folder that I'm using for the rest of my project, and I'll just maybe call this my stakeout drawing. Use the same horizontal scale as the other one. And I'm going to create a brand new stakeout coordinate file. I'm not bringing any data in from this one, so I'm just going to say I've got no points to bring in. I'll just choose Next. And what I want to do now is to sort of give myself an idea of where I'm at. I'm going to go into and reference that AutoCAD drawing and attach out in my folder the drawing that I had created earlier called Win. And I'll just place it same origin, same scale, rotation angle is fine. This is going to be an attachment. I'll say OK. And we've got our drawing loaded and attached, and we'll say OK on that. And when I zoom extents, there's my drawing as a reference. As I'm building my data set in here, the other thing that I want to do is maybe show the limits of the surface model that I created for my survey data set. So I can go under my civil configuration now, and in my surface menu I want to draw the surface boundary, and I'm going to put this on a this is actually my survey, so I'm going to call it my V topo boundary layer, and I'll bring this in as a 3D polyline, just choose OK, and go grab that existing tin that I built with my AutoCAD session. And we will use this boundary for maybe the placement, if time permits, for a little detention pond down in here, because there is sort of a little bit of a ravine that runs there, and maybe we want to capture some of that runoff water for irrigation purposes or for stormwater control or what have you. But the purpose of the session right now is to go through and take the center lines that have been generated and form a quick little roadway network from them. So I'm going to go ahead and start off into my Roads menu and choose Road Network. We'll create a brand new one in here. We'll call this the Trout Run. I should call this Middle Kalmar Road. I think that was the main one. And when we're building this road, we want to tie in the new roadway geometry into the surface model that was just surveyed. So I'm going to go into my settings menu to do that and choose the existing ground surface model. And for stakeout purposes, I want to create maybe a roads surface model. I'm not going to contour this one. I'll just create a brand new one in here, just call it roads. And I will also create and merge that roads surface model with my existing ground surface model and create a brand new one in here called merged. And for stakeout purposes, we're going to write this roadway network information out to a SurvCE stakeout file, and I'll call this Middle Kalmar. And for the rest of this, we'll just leave OK for the rest of the defaults. Oh, the only thing else I do want to do is make sure that for my output file defaults, I'm also going to create existing ground profiles for the design that's coming in here in a minute, because we'll use these profiles to generate a best fit profile for my design considerations. So let's say OK. And when I go ahead and choose Add, I'll grab the Centerline files that my surveyors had graciously created for me. I'll choose the Middle Kalmar Road. It's going to say what kind of design profile do you want to use. It's just going to give me a default starting profile for now, which I'll say is Middle Kalmar, which is fine. And if I take a look at it, it provides basically a straight grade profile from where the roadway starts down here at the south end of my site up to where it daylights at ground at the north side of my site. Again, I don't have any vertical curve information in here. We'll go ahead and generate that here in just a minute with the best fit profile command. I do also want to go ahead and grab a template. I've built one yesterday. I've called it rural. Just go ahead and open it up. And I'm not going to go through the template creation process. Again, this has been set up for what I want for my county roads that I'll be building here in just a moment. I won't be going through any of the additional input files here today. We don't have enough time to do that. But I'll just choose OK. And then go grab my second Trout Run road. Screen pick that, or get that polyline file as well. And same kind of thing. We'll just use a default profile. Open it up, use the same template, and choose OK. So this is the start of my roadway network in here, and I can process this right now if I want to. What I'm going to do, though, is go out and just to be safe, I tend to like to dismiss my doc dialog box. It does allow me to work with all my different commands. I just find it a little bit safer for me to actually go ahead. I'm going to create my best fit profiles. So if I go into my profiles menu and profile utilities, I'm going to work with best fit profile. So we've generated some existing ground profile data based on the best fit center lines that I generated, so now I want a best fit profile. And the profile we want to take a look at that we want to process, we'll start off with our Middle Kalmar one. There it is. And we have some snap tolerances and settings in again. And we'll say that maybe we want to go ahead and we want to do some milling on this particular road, and this would be the type of profile I want to create. Minimum vertical curve length of 300 feet. And we'll say OK. And again, we'll take a look at all the different residuals. We can remove things out of here if we choose to. This looks OK. And it's going to then generate a brand new profile. And I'll use the same name that I had been used or that I used earlier. And if I take a look at the other road in here, actually it looks like that should be okay. I think what I'm going to do is just sort of skip over the best fit profile for my Trout Run for right now. So if I go back under roads and look at my roadway network and look at my Middle Kalmar Road and the profile associated with Middle Kalmar Road, we can now see that we've actually got it conforming to, or better conforming to, existing ground, but with the minimum vertical curve lengths that I had specified for my design. It's also tying in with the Trout Run Road down here at this point of the intersection. So these two roads are going to be fitting together very nicely. And if I'm happy with this, I can just go ahead and process this. Let's just take a quick look at the Trout Run profile. And Yeah, maybe I'll just throw in one vertical curve in here. So I'll just pick in a PVI location, just drop something in, maybe give it a 400-foot vertical curve length. And we'll say OK. And that looks pretty good. If I need to, or if I want to edit this and maybe just change it around just a little bit, I can. And I'd say from a design perspective, that's going to be fine. So we've got our roads, at least the required input files built in here. I'll just choose OK, and I'll go ahead and process this roadway network. And once we've processed the roadway network, we can take a look at the resulting surface model with our Surface 3D Viewer command. We'll take a look at the merged surface model. And based on this, we've got a data set that's been newly generated for me. If I want to change some of the shading aspects on this, I can apply sort of a smoother looking shading to the site. And I'd say for my design considerations, that'll be good. We want to now go ahead and get this information staked out in the field. Before we do that, however, I forgot one more thing that I want to put in here, and that is a design pond, a little detention pond in here. So I'm going to exit from my roadway network and save my changes, and then bring back some layers that I want to see. So in my layer control, I want to go ahead and make sure, let's see if I got them in here. Okay, so I don't see the reference layers in here. I can go into my view, and I can say, yes, I want to toggle on my cross-reference or my X-reference layer visibility inside of Intelecad. And what I want to do now is go down and find the break line layers that came in from my survey. And let's see, I think if we had, there are features in here that I wanted to bring in. I don't know if there was anything else I really wanted to see. That should be good for right now. Let's take a look. I wanted to get to the trees in here as well, just to have those, but I don't remember what layer those went to. It's not the tree layer. Okay, so anyways, we'll just go with this. All right, so what I've got in here are the break lines that came in from my survey configuration, and what I want to do is put in a little detention pond down in here to sort of capture the flow that is traveling along this little ditch that's out on the site. And I'm going to just go ahead and, for my layer control, put this in as a maybe like a sea, stream, or water kind of utility area. So I'm not too particular, particular about what layer I really need to go to. Let's make this just a storm structure layer, if you will. So it's a detention structure. So I'm just going to put in a polyline down at elevation 0. I'll just whip in something in here real quick. Maybe we want the pond to sort of look like this. And we'll close it up. And this is, again, through my inquiry and my drawing inspector, if I hover over this, this is just a lightweight polyline at elevation 0. So I don't really know what the design of this pond needs to be. We'll get that information figured out here in just a minute. I'm going to go into my surface menu and choose Design Pad Template. And I'm going to tie the slopes of the surface model into a surface file. We're going to go outside, and we're going to use a sloped pad. We're going to give it the bottom of this pond a 2% cross slope, and take the rest of these settings, and everything looks okay in here. And I'll just choose OK. So we'll pick off this pad polyline, and we're going to tie this particular pond back into the merged surface model that came from my roadway network. Specify my fill slopes if I'm infill, or my cut slopes if I'm in cut. And it's read the surface model along the perimeter, and it found the elevations ranging from 950 to 959. And I'll put this pond, let's say, 4 feet below original ground, so I'll run this in here at about 946 feet in elevation. And the slope direction for my pond bottom will actually sort of come in that direction. We'll go through, run the calculations, get the volume report, and allow you to place this information on screen. I'm happy with this report, and I'll just choose Exit. And do I want to adjust and redesign? At this particular point, I'm going to say no, I don't need to readjust. I'll just leave it as it is. I will, however, want to write this to a triangulation file, and I will merge this pad with the target surface model. So I'll have a new merged complete, let's just say. And then remaining prompts, I'm not going to contour this and just leave this in here, and I'm going to use this information now. So again, if I go back under and look at my surface model in my Surface 3D viewer, I have a new surface model file built that actually has that pond now located in it. Right there. So this is what I'll be building out in the site, and now it's ready to go for stakeout. So this might take a few seconds to get loaded up here. We're running just a little short on time, so I'm going to exit out of my Intelecad session now and get my data collector hook back up so we can load this data back out for field stakeout. Before I do that, I'm going to also, just for brevity, go ahead and detach my survey drawing, so I'm left with just my civil, and we will exit out of Intelecad and then rehook up the data collector. So while this is synchronizing up, Aaron, do we have any questions that I can address while this is doing its thing?
Sure. Hang on, I'm trying to answer one. One guy was asking about the CAD standards, and they are supplied. Just responding to that real quick. One question that I typed in that I was not sure about: if you're running SurvCE, and you know how you can build a template for a particular code, such as a curb line, flow line, gutter, and all that, and you have that code set to 2D and 3D inside the Carlson Survey. I guess I have not actually run into this, but it draws the 3D line work based on that template, but it only draws the whatever shot you're taking, whether it be the back of curb, it only draws the 2D just on that particular shot. It will not follow the template on the 2D line. Are you familiar with that, or?
I'd have to digest that question a little bit more thoroughly, so let's hold that one towards the end here. So let me get through this last little part of it here, and then we'll see if we can get that one answered here in just a minute.
Okay.
All right, so we've hooked up our collector here now, and Windows and Windows Mobile have synchronized, and what I want to do now is load up SurvCE and bring in the engineering drawing, or my stakeout drawing, for stakeout purposes. So again, we'll load up SurvCE, and what we'll do then is indicate that we want to use the existing stakeout coordinate file, even though there aren't any points in there. We're going to say we want to select a new or an existing job, and the one that we want to use is the stakeout job that came from the design. There's no data in here just yet. We're going to use this data as a means to collect and store my stakeout points that I'm placing on the field. Again, this is based on Iowa North. We'll green check on that. And as we bring this in here then, what I want to do is go right into my map screen and bring in the drawing file that I created with the design. So I'm going to go into my File menu, choose the DXF, DWG, and DGN option, and I want to import the DGN, or the DWG file, excuse me, by just simply selecting that. Choose some options in here. If I have any AutoCAD point areas, I want to bring those in. These are all would be Carlson points, are going to be brought in. So I'll just screen check on this, and we will then read up all this information and bring that file directly into SurvCE. Once that's done, we're going to jump into the road menu, and we'll stake out the road using the SurvCE stakeout file that our road network routine created. Okay, and again, this is all being handled on the data collector itself, so it's doesn't have the horsepower of a PC, but it's clipping along doing pretty well. And it certainly saved me the time of having to create specific DXF files from the office Software. All right, we're now reading all these layers that are in, and that's the one thing. Generally, as a best practices, what I'd probably want to do is before I hand this drawing off to SurvCE for stakeout purposes, rather than having 310 layers in my drawing file that I would probably never use, I'd probably want to purge those layers from the drawing so I don't have to wait through that startup process. But again, take a look. Here's again the information that was generated inside of the office with our little pond that we built in there. And what I want to do now is go ahead and run some stakeout routines. So I'm going to jump into the Road tab of SurvCE, and I'm going to choose the Stake Road option that is available with the advanced roading functionality of SurvCE. And I want to go ahead and load up a RoadNet file. The one that I want to bring up is my Middle Kalmar Road, and again, this was created from the RoadNet application. And it'll go ahead and load up all the geometry, so in a single package, we're delivering the center lines and the curb returns and the profiles and the templates and all the design information that basically went into this particular roadway network. Once we've loaded that file, I'm going to go ahead and choose the element that I want to stake out. And it'll take me into my drawing in here, and all I have to do then is pan down and choose, maybe I want this segment of the road. I want to get that main one. So here's my Middle Kalmar, the main segment of that road. When I've got that in here, just green check on it. It's going to then tell me, hey, here's the Centerline file, the equivalent profile, the template that you want to use. Is there any optional files in here that you want to use? You can go ahead and pick those. But when I'm ready to go, I can, again, just green check. Indicate which point that I want to stake off. So here's my, my first station. I'm going to stake 3 feet off of the, in this case, my edge of pavement location. So that's the point I'm staking out right there. And when I'm ready to go, I can just green check. And I've need to then sort of navigate over to or walk over to my spot, and as I'm traveling along in here, I have to control my keyboard here through my mouse control. So again, we're in simulation mode, and we're walking over to our point that we want to stake out. And as we are getting there, SurvCE is also providing us information on how far we got to go to get there yet. And as we start to narrow in, the target will eventually change here. We want to make sure that we get ourselves into a fixed GPS mode. I'll show you that in just a moment. And let me slow down here just a little bit so I don't run past my point. And you can see that we're starting to narrow in on our point. And when we're ready to go ahead and stake it out, all we have to do is hit the Ask for Store option, and then this description information will be read into and recorded into the data collector. So we're getting a little bit closer here now, and again, we still need to do quite a bit of fill in here based on my GPS simulation mode, so this isn't quite realistic, obviously, but there we are. We're narrowing in now, and we've got just about 1/10 to go, and obviously I could probably walk there a little bit quicker out in the field than I can navigate with my keyboard here on my virtual simulator mode, but I want to just double check and look at my monitor sky plot. And there we are. Now we're back in our fixed scenario. So we'll record that shot and just green check on it. So here's station, the edge of pavement code, our offset, including our 3-foot offset, and then what we need to do to get to that particular design elevation. We store that point, and then we're ready to move ahead to the next station or to a different station. I can choose that and different offsets, and when I'm ready to go, again, I just repeat the process, green check, and move up to my next station and start to go to work on that one. So that basically covers the main bulk of the information here. And again, just sort of recap, we use SurvCE to collect some data, brought that in using field codes that have been conformed to both the office and the field device, and used all that information very electronically, very cleanly, no loss of conversions or anything like that, and provided that nice tight collaboration between the office and the field products, again, for which Carlson is known. So that concludes my formal presentation. Aaron, what kinds of questions do we need to address?
There's been quite a few coming in here. Let's see. So how do I stake subgrade entities?
Subgrade actually has to be conformed through the use of, let me bring up that, if you're staking subgrade, you can, generally the way you'd probably do it is to actually create just a subgrade only template inside of the Office product, and don't worry about all the pavement information is one way to do it. I believe we are exploring some other subgrade staking routines, but as of right now, when I'm staking out my road, making a screen check on this, if I take a look at my template, one thing I could do is just even come in here and make changes to the template that I want to work with, and go ahead and choose. That's the one I want to use. Actually, I want to go back into my template editor, excuse me. So if I go back and take a look at my template, here's my template, and I can actually go through, and if I need to either change the vertical profile or change the grades of the template and just use sort of a subgrade template. Other questions?
Well, let's see here. I would like to help out this one gentleman that typed this up, but I'm not sure I knew exactly what he was talking about because I was trying to field other questions coming in. But he said you were looking at something, trying to check your residual numbers.
Mm-hmm.
He was said, what are you looking in for the residual numbers when you said they were okay?
I was looking for shots that, anything that was, if I had a residual number, the ones that I've seen when I've had bad ones, and this is where sort of the big understanding of the residuals comes in. And I'm not going to claim to be a big expert here on this, but for shots that have residuals like larger than 2 or 3, I've seen some that are 13, 14. Basically, it's just how far off of the center line are those shots, the way I sort of look at it is if a shot was collected out in the field and it's within 2 or 3 tenths, 4 tenths maybe of the actual center line location, I'm pretty sure that's a good spot. What I'm looking for are things that are outliers that just don't look right compared to the rest of the data. So there's not going to be, I don't think, a real hard, fast rule here. Certainly it'll also depend on the quality of the data and a lot of different things. But again, same kind of thing even with the best fit profile. Is there a busted elevation in there somewhere? It's a shot or a point that just doesn't look right, and that's where the designer is going to have to use a decision about what's good and what's not.
Correct. Yeah. So I got asked. A new question just came in. The site has been once the site is designed, the design is done. The site has been resurveyed and possibly even staked for certain features. What is done with the collected staked data? If I'm understanding the question correctly, I guess the collected staked data, you can actually go back and check your deltas on them and make sure that everything is correct.
Yeah, I mean, certainly you can get reports. Here is actually what was staked for the shot that I grabbed. So this is sort of showing, what was actually staked out in the field, the coordinate location that was, so if there was any kind of a problem between the contractor and the surveyor who was laying the site out, I could say, here's what we gave you, and you have sort of the electronic record. If you want to continue to hang on to this data, you can. It's obviously, the surveyor and designer's choice at that point.
Yes. You can actually create a cut sheet that'll tell you your deltas on too, that you can get a report from to make sure that what was done is is correct.
Right.
There's been quite a few questions. I think I tried to address most of them, I believe. Hopefully everybody is seeing on the screen the email addresses. There was a couple that I had asked to just send us an email so we could work with, specifically the one on using a template file for a single code like a curb and gutter. If it's selected to do a 2D and 3D, I guess the gentleman said he's getting all the line work for the full template on 3D, but he's not getting it on the 2D. And I'm not sure if you're familiar with that lad or not. I haven't actually checked.
We'll have to let's check into that one after the session.
Yeah. So.
All right, well, for anybody else that has any questions, feel free to drop me an email or give me a shout. Actually, I do have a presentation this afternoon that I have to give, but otherwise I'll be available. So we're at the top of the hour now, so we would like to thank everybody for attending today's presentation. Again, a recording of the session will be made available back up on the Carlson movie site, and we thank you for your time.